Welcome back everyone to another episode of the Doom series, and in this video we are going to get started with using our GL node data to construct the sectors and floors for our sectors. Alright, so to begin with, we are going to start by opening up our wad.c file, and in here we are going to read the GL maps important data, which is checking for the correct version. So GL map contains many versions, and we are going to check for the correct one. So first of all, we'll just define all of the indices of the sectors. So for the vertices, for the segments, for the subsectors, the sector that the one that we are actually going to use, and then of course the GL nodes of the GL binary space partitioning tree. So to start with reading the GL map, we'll first of all, as I said before, we are going to ensure that we have got the correct version of the GL nodes. So in order to verify that, we'll need to first of all check a magic identifier at the start of the vertices node. So to check for that, we are going to get our WADS data and the lump data of the vertices node. So we are going to get the map index, add to that the vertices index, and we are going to compare it with G and D2, which is the magic identifier for GL nodes version 2. And the version 2 is the one we need. If it's not equal to that, which means it's some other version, we are gonna exit, which means return with an error. And if the segments 1 is 3, because GL version 3 also uses G and D2, so if the segments 1 is 3, we are going to check for that, and if that's the case, we are going to exit as well, because we do not support version 3. Version 2 we only support that, and you can see it gives no error, which means that everything is working. So now we can start to read the actual data. So for that, we'll create a function here called read GL vertices, which will of course take a pointer to a GL map along with the lump that we actually need to read the vertices from. And now we can just go under glmap.h, and inside of this you can see that we are going to copy the basic map data, the one we are gonna use to have the vertices here, and the other data we don't really include that in the GL maps, and we're gonna also include our vector header of course and everything else. And now we can basically just copy the one implementation for the normal vertices, but we are gonna of course modify a couple of things. So first of all, each vertex is going to be 8 bytes. So each value is going to be 32-bit integer instead of having being a 16-bit integer. So we're going to change everything to 8. And the I value that we are going to use for the index is going to start at 4, since the first 4 bytes are magic numbers. So this is going to be 4 here, and now we need to understand why this is 32-bit. So these numbers are actually in 16.16 fixed points, so we do need to convert them to floating point numbers. So for that we are going to convert, first of all read them as 32-bit integers, and then we are going to cast that to a float, and in the end we are going to divide that by 1 left shifted to 16, which is the same as 2 raised to the power of 16. And the reason we divide it by that is because there are 16 bits in the decimal part, and yeah, that should give us the x and y values correctly. So in the engine.c I've got some code for printing these out, and if I run this, you can see that our program goes completely out of bounds. The reason behind that is of course because we never actually call this function. So in here we'll just call the read GL vertices with our map, and for the lump we'll just get the vertices lump here. And one more thing that might be good to do is that when getting the lump size, we're going to subtract 4 from this, because well, the first 4 are, as I said, they are not really needed. They are the signature, and you can see that this does read the values correctly, and these are the correct values in floating point now. Alright, so now we are going to load the GL segment. So for that we are going to define a struct here called GL segment, and we're going to type def it, and for the actual values this segment contains, for the GL segment structure consists of 2 integers representing the start vertex and the end vertex index for the segment. After that we will have 2 more integers having the line def and the side of this segment, and we will can also have a partner index here, but we won't really need that, so we will leave that out. And we will create a function here for reading the segments, and it will basically have the same signature as the read vertices one, and the basic structure is going to be similar as well. So we are going to just go ahead and change this to use 10 byte. Each segment is going to be 10 bytes, so we are going to change this to GL segments, actually not segment. And we are going to set the max number of segments here, and we are also going to allocate the actual segment data with the correct size of GL segment, and we are going to not subtract anything, and we are going to divide this by 10. We are going to remove the code for the minimum and maximum, and we are going to add the number of segments and the actual array here as well. And now going here, we can modify this to actually allocate it with the correct size, and we are going to read our own custom data of the segment, and we're going to start at index 0, not at 4, and we're going to increment it by 10. Anyways, for the start vertex, we are going to just read the I16. So we are going to actually, this is reading like signed, unsigned values. So we're going to read unsigned values, and we're going to read the start and end vertex first of all. In this is 0 and 2 at offset 0 and 2 of the lump data, and then we are going to read the rest of the data here as well. So that's going to be at offset 6 and 8, and actually that's not right. It's not going to be at offset 6 and 8, and it's going to be at offset 4 and 6 actually. So we are going to read this data here, and it's going to be our line def that we have got, and it's going to be the side that we have got, and we are going to leave the partner one out. So after this, we are going to go up here, and we're going to just call the read GL segments function, and we're going to pass it our wad and map lump here correctly. And yeah, that should actually read the segment data, and we need to make sure we're calling the correct function. If I run this, you can see it gives no error. We get exactly the same result as before. So now we can move on to the process of reading the subsectors. Okay, so in here we are just going to define the subsectors here by having a struct GL subsector, and this struct will only have two values. The first one is going to be the number of the segments that this subsector has, and the other one is going to be offset to the first segment, and these segments will already be in order. So now let's go down here, and we are going to copy and paste this method, and we're going to just change it to GL read subsectors. And for the reading of subsectors, each subsector is going to be just 4 bytes, not 10, and we're going to divide this by 4. We are going to change this to only read twice, and we are going to use map subsectors here. So we are going to change this to use subsectors, and in here we are going to change this to use subsectors as well, and then here number, we are going to also define the number of subsectors. And when we are allocating the memory, we are going to use num subsectors, and we'll allocate the size of subsector. Now we are going to change this to 4, and of course there is no subsector, there are no subsectors defined here, so we're going to just go ahead and define the number of subsectors along with an array of subsectors. And if I go in here, we should be able to now change this to read the correct data, and that's not actually working, and the reason behind that is that we haven't got this change to subsector here. And now we can set the number of secs first, and then the first segment that we want, and this gives us our format basically. And we're gonna call this method in our main read GL data function, and we are gonna go ahead and create an prototype of this function up here, and these all should be static actually. And yeah, that's pretty much it. We are gonna run this make, and you can see it doesn't give any seg false or anything, which means that our code is not broken. And I'm gonna remove the vertex printing code from engine here, and all that's left to do now is to actually use this to construct the sector floors and ceilings. And that is what we'll do in the next video, so stay tuned for that. I'll see you in the next one. Make sure to like and subscribe as well so you don't miss it, and share this video with other people as well, and bye.